Here's the demonstration for using Solver on the TI-83. In the section 3-4 slides at the end that are out there on Blackboard, I recommend using Solver for the periodic compounding interest, for future value, and for present value. And I think the easiest way to do it is, rather than typing those equations in individually each time in Solver when you want to use them, is just put the three equations in the y1, y2, and y3 function variables, and then just reusing those when you want to switch back and forth. So that's what I'm going to show you. So to put them into the y1, y2, y3 function variables, you start off by clicking y equals. And I've already got those equations entered, but I'll go ahead and re-enter the y1. Let me clear it for now. And what I want to put in is the equation for compound interest. Now, in Solver, for the TI-83 and 84 at least, the equation that you enter has to be some equation that equals 0. So rather than, I can't put in A equals P times 1 plus R over M to the power of MT, I have to make that into an equation that equals 0. So I just subtract the right-hand side from both sides of the equation. So I end up with alpha A minus alpha P times 1 plus alpha R divided by alpha M, close parentheses, power, open parentheses, alpha M alpha T, close parentheses. So that's the same thing that I had in before, and I just hit enter. So we can now see that y1 has the equation for periodic compounded interest. A is the amount you have at the end, P is the amount that you put into the account, R is the yearly rate, M is the number of compounding periods per year, and T is the time in years. In the y2, I've got the formula for future value. F, which is the future value, minus P is the payment, 2 open parentheses, 1 plus I. I is the interest rate per period, which is R over M, to the power of N, and N is the number of payments, which is the number of compounding periods, which is also M times T, minus 1, close parentheses, divided by I. So for the y2 equation, F is your future value, P is your payment, I is your interest per compounding period, and N is the number of compounding periods. My y3 equation, I've got the equation for present value, where I'm using V for present value because I'm already using P for payment. I can't use the same letter for two different things, so instead of using P for present value, I use V. And all the rest of it is just the equation. So I've got those in y1, y2, and y3. All right? So I can get out of that by doing second quit, and I want to get into Solver. So I click, to get the Solver, you click the Math button, and you scroll down to the last option. Whether it's a TI-83 or 84, the last option on the Math button under the Math menu is Solver, and you hit Enter. Now I've already got some stuff in here, but let's go ahead and change and put the periodic compounding interest in. So I go up arrow to the equation equals line, and you just have to remember y1 is, in my case at least, periodic compound interest with a single initial payment into an account. Y2 is the equation for future value, and y3 is the equation for present value. So we want to use the periodic compounding interest formula, and so I want to put y1 in here. And to do that, you have to click the vars button and then go over to the yvars menu by right arrowing once and select function. And, if you hit enter right now, y1 is the equation you pick. If you go down, you can pick y2 or y3. And just remember that if you're working on a periodic compound interest problem, you're going to pick y1. If you're working on a future value problem, you're going to pick y2. If you're working on a present value problem, you're going to pick y3. So I want to pick y1. So I just hit enter there, and it puts equation equals y1, which is going to have the equation that's in y1 up here in it. So if I down arrow now, see, I've got my A, P, R, M, and T. So my problem, any problem I get for periodic compound interest is going to say, give me 4 out of those 5. So let's say I put $500 into an account. So my P is 500. That earns 7% per year. So my R is 0.07, compounded monthly. Let's say compounded quarterly, so I'll change that to 4. And I'm going to leave it in there for 2.25 years. So it's going to be 9 quarters. How much is it going to be worth at the end? When you use Solver, any problem you use with Solver, you're going to be given 4 out of these 5 for this kind of problem. The present value and future value ones, there's 4 variables, so you're going to be given 3 of those, and you're going to solve for the one that you don't have. And so in Solver, to solve something, you move your arrow to the line that's got the variable you want to solve for. Okay, because we were given, okay, $500, 7% per year, compounded quarterly for, 9 quarters, which is 2.25 years. You hit the alpha button, and the solve function is the alpha function above the enter key. And it tells us that after 9 quarters at 7% per year compounded quarterly, the account is worth $584.49, rounded to the nearest cent. Okay, and all of Solver works like that. You're going to have an equation in Solver that's in, let's go up 1 in here. Okay, and you're going to be given however many variables there are. You're going to be able to figure out what all but one of them are, and type those in. In whatever the format is that it needs to be typed in. Remember, in this particular equation, R is the yearly rate, M is the number of compounding periods, and T is the time in years. Okay, and then move your cursor by up arrowing, down arrowing. Let's say, well, what if the N value was 584.49, and I wanted to see what the interest rate needed to be in order to get that. I would put that in there and do alpha solve on the interest rate, and it tells me, it's 0.069997, which would round to 0.07 per year. The reason it's not exact is because when we solved for A, it wasn't exactly 584.49. It had a bunch of decimal places out here, and so that's why, since I'm rounding it to the nearest cent, which is what you have to do, I get something that's not quite 0.07 here. If I put 0.07 back in here and solved for the number of compounding periods, alpha solve, again, it wouldn't come out to exactly 4, but you're never going to get an investment that pays you 7% per year compounded 3.98 times per year. That's got to be a 4. Okay? So let's go back and do a future value problem. And my future value equation is in y2, so again, I just do vars over to yvars, select function, and I want to put y2 in there this time. So when I hit enter there, now all of a sudden I've got the variables for F, P, I, and N. So let's say I wanted to put $500 per month into an investment that earned, or let's say $500 per quarter into an investment that earned 7% compounded quarterly. Well, now in the future value equation, the version of it that we're using is the I is the interest rate per period. So 7% compounded quarterly is 0.07 divided by 4. And just enter it like that. Don't figure out what 0.07 divided by 4 is and then write it in. Just put it in like that. The calculator will convert it to the correct number. And let's say, again, we were going to do that for 9 quarters, which would be 2.2, which would be, in this case, I have to put it in as 9, okay? Because I'm going to put 9 payments of $500 each. Now, it's going to be worth a lot more than the $584 or whatever it was, because I'm putting 9 payments of $500 in, not just a single one at the beginning. So if I want to solve for future value there, I just do alpha solve, and it tells me that the value is $4,828.21. Okay? So notice that I do have to convert I and N. This is not R and T anymore. It's the interest rate per period and the number of compounding periods. And there's no place to put M. You just have to know that, oh, that's quarterly payments, you know, rather than monthly payments or yearly payments. If I want to use the present value equation, I just go back up to the equation solver, vars, y vars, hit enter for function, and go down and pick y3 as my equation. When I hit enter there, now I've got my y3 equation. So let's say I wanted to pay off a $10,000 loan. That was payments were quarterly. Actually, I think what was the amount for the total on the previous one was like $4,800 and something. So let's say I want to pay off a $4,850 loan with the same thing, 7% compounded quarterly, and I'm going to make payments quarterly, and I want to do it in 9 quarters. What's my payment got to be? Again, I put my cursor on the line that I want to solve for, alpha solve, and it says my payments are $587. So I guess the V in the previous one was a little bit higher than that, or the F was. So 9 payments of $587.13 will pay off a $4,850 loan at 7% per year, compounded quarterly. That's what this number is, in 9 quarters. Let's do a mortgage loan. Let's say I'm borrowing $120,000, and the mortgage loan is 4%. Let's say 4.5% per year, compounded monthly. So it would be 0.045 divided by 12. That's 4.5% per year, compounded monthly. And let's say it was a 20-year loan. So I would have to do 20 times 12. So I got 240 payments at 4.5% compounded monthly, and I want to see what the payment is. So I move my cursor to the P equals line and do alpha solve. So to pay off a $120,000 mortgage in 20 years at 4.5% per year, mortgages are always monthly, it's going to cost you $759.18 per year. So let's put 759.18, since that's what your real payments are going to be, and figure out what the present value for that is. Alpha solve, and you know, it's $120,012. So what does that mean in real life? If you really did borrow $120,000, your last payment, instead of being $759.18, would probably be $759.07, because you would have paid 11 cents too much or 12 cents too much. It would have been $759.06. You would have paid 12 cents too much over the period of the loan with those payments, and so your last payment would have been a little bit lower by 12 cents than the total previously. So that's how you use solver. Again, step through it again. You put your 3 equations for continuous or for periodic compounding This is with a single initial payment that sits in an account for a while. Your equation for future value and your equation for present value in y1, y2, y3. Then when you go to solver, you just up arrow to the equation equals in, and depending on what your problem is, you go to vars, y-vars, function, and pick, the function that you want for, again, periodic compounding, future value, present value. When you down arrow, it gives you the variables you want. For all three of those, you're going to know from reading the problem what all but one of the variables is. So you type in the values for in this case, the 3 out of the 4 variables that you know, and you put your cursor on the other line and do alpha solve. So that's how you use solver for periodic compounding, for future value, and for present value.